Go.
Yeah, I'm talking to Mr. Simon Link, the creator of the LinkTest software that I used in my public speaking unit of a English as a Second Language course. Basically, he introduced the software to the kids. I had video of that, and I've since ate that video, trying to share it between devices. So I asked him to sit with me again today and just basically briefly introduce what LinkTest is and how it works.
Thank you. I'm happy to be here, and I will start up the test. Shall we do that?
Let's do it.
Okay. Right. We can edit this out.
There we go. LinkTest it is.
Yes. Okay. So this test I developed to help students achieve more of a native style pronunciation, especially students who are older and have pronunciation that is not likely to change so easily.
Not as malleable as the younger kid.
Right.
Sure. How exactly does it work?
Okay. There's a lot of work recently on speech recognition. And you may see things like Siri, where you talk into your iPhone,
Sure.
and the voice recognition will interpret what sound it gets and translate that into text words, and then either display the text or use it somehow. So that feature is very useful because students can read a passage or say some words and then see immediately what the output is, what the algorithm interprets from that.
They get immediate feedback. Yeah.
Immediate feedback. And so, for example, a lot of students say from Japan, the L sound and R sound in Japanese are identical. The same symbol, the same sound is used for both.
Same in Korean. It's Ria, which
Okay.
is L and R kind of combined. Yeah.
So in English, there may be more or different phonemes. And students need to be able to practice, but to get some feedback, because their own ears have maybe never heard these sounds and cannot distinguish between the two.
All right. So yeah, at this point, I've already run through basically the speaking and the use of the LinkTest with the students, and we did it we did it two ways. Each student had a 3-minute and a 5-minute speech, and they would give the entire speech on LinkTest, and then basically they were counting the number of words in the speech, and then making a fraction out of the number of words that the LinkTest got correct that they meant to say. Yeah. The second way we did it is I had the kids speak to a friend, have the friend give them 10 pronunciation issues that they had with the speech, 10 things that they needed to work on, 10 pronunciation suggestions. They took those 10, put them on LinkTest, and LinkTest basically recognized them practicing those words. I don't know if I explained that well. Basically, they use those 10 suggestions to practice on LinkTest.
Okay. Now there are two issues with using voice recognition to help pronunciation. Some software adjusts to the individual user's particular pronunciation. So as the more you talk, the more the algorithm adjusts. Now that doesn't work well for non-native speakers because the software will just adjust to that foreign accent. And that's what we don't want. So this software uses an algorithm that does not adjust. It uses a database of thousands of hours of native speakers reading passages.
Okay.
And that creates a database. When a user speaks into the microphone, the algorithm searches the closest match. It essentially guesses at what you're saying. So this does not actually take the physical sound and represent it with letters. It is a statistical match. And so you if you're going to say a long speech, you have to put in punctuation, periods, commas. You may have homophones, a word that's an identical sound like there and there, in which case you don't.
Does it use context at all?
It does, because when you think about it, the database contains patterns of speech.
Okay.
So I'm going to the store would be a common pattern that's recorded. I going to the store really doesn't exist. It's not a common pattern at all.
Sure.
So when this algorithm, if you make the mistake, I going to the store, the algorithm might correct your English word, which would be good for an ordinary user, but when you're analyzing pronunciation, you don't want that.
Sure.
So it's best to check short phrases or single words, because you're not checking the grammar, you're checking the pronunciation.
That's basically what we found. I think for different reasons we found that. Basically what would happen is a lot of the times they would be giving their speech and it would get to, I mean, they're 3 to 5 minute speeches. So they would get to about the 2.5 minute mark. And then you'd go overload it, basically, is what happened.
Well,
it worked much better when we had the 10 suggestions the students went through. Could you explain this right end again?
Okay, so of course it's all right, you can take your iPhone and talk into it and see the output, but I want more of a test. For example, does it match or doesn't match? And I want immediate feedback for the student. So on the right, you can enter your own list of words or phrases, or I have here a preset list, say words that start with R, okay? Words that start with TH, V, or intonations such as small, big, small, tomorrow. So students can target a particular sound and work on it without having to enter all these words. Now what happens is every 1/10 of a second, this speech is analyzed and matched with these words on the right. And if there is a match, that space should turn green. And the student immediately knows, without having to read, that the word is a match. So
Can I try?
Sure. Start it up for you.
Is it ready?
This is an intonation pattern like tomorrow, and you'll click the mic and give it permission. Go ahead.
Nintendo. I got it. Tomorrow, and you can see where it's lighting up green as I say the word correctly. Banana fish. Nothing lights up.
No, that's not a match.
But it's reading everything we say.
Sure, so you can actually see what the close